In the lesson that follows, we continue with our plot of a line graph which was introduced in the previous lesson, and now we explore and extend it further. In the last lesson, we constructed a line graph visualizing sales from this online office supply store based out of Canada. In particular, we visualized sales in the year 2016, monthly sales across 3 provinces: Alberta, British Columbia, and Ontario. And the sales visualized by way of a line graph are as shown. Now what we'll be doing is we'll be adding various further elements to this chart. But before doing that, notice this sales pattern doesn't show any specific patterns, so to say. Though one could say that Ontario sales generally is higher than Alberta or British Columbia sales. But those things apart, let us now add chart titles, axis titles, see how to change fonts, format axes, and so on. So to add a chart title, all I do is I select the graph and notice on the right hand side, there's a plus sign. So if you click that, you have these various options. So there's a chart title option there. You click that arrow sign there. There are a couple of more options. So I'll add a chart title above the chart. So there's a chart title added. I can also add axis titles. Again, I click on that arrow next to axis titles. There are options available. Do I want a primary horizontal title, a primary vertical axis title? I'll select both. So now axis titles have been also introduced in my chart. Now I can go to my chart and put in whatever names I want. So the chart title I could give monthly sales, the year 2016. I could then also, if I want, boldface the title. I select that text box, go to home, select the bold option. I could also change the font size. The horizontal axis title, again, I click on that. I can change the title. Maybe I'll call it months. I could again select the text box, change the font to a boldface font, maybe increase the font size to size 12. I could do the same thing with my vertical axis. I select my vertical axis and change it to, maybe call it sales in dollars. I could once again boldface that font, change the font size, and so on. I could also shift the text box. Next, let me change how the y-axis and the x-axis look. So beginning with the y-axis, I select my y-axis, and maybe I do not want to see those decimal points there. Maybe currently the y-axis increments in increments of $20,000. Maybe I want to change that increment. So how do I do that? I select my y-axis, do a right click, format axis. On the right hand side, notice a host of options open up. Axis options, tick marks, labels, number. I click on that number, scroll down. Here I have an option to see as many decimal points I want. If I do not want to see any decimal points, I put a 0 there to decimal places. I could also scroll up, and here I have an option. You would notice it says axis options, units. The major unit is $20,000. That is, it'll increment it in $20,000. I can change it to 10,000 if I want to increment it in units of $10,000. So now you would notice my y-axis, it increments in $10,000, and also I have done away with my decimal places. Next, let us change how the x-axis looks. So once again, I go to my chart, I select my x-axis, do a right click, format axis, and again on the right hand side, a host of options show up. So to begin with, let me first change the font size of my x-axis. I select my x-axis, go to home, boldface it, and maybe change the font size to size 10. Next, I want to change the appearance of my x-axis. So I could change how these labels look. So I take my cursor to where it is currently showing, where it says size and properties. I click that icon. And now I can change the text direction of my x-axis. Currently it's horizontal, but I could rotate it, make it vertical. I could also, if I want, make it stacked. I could also, if I want, give a custom angle to the text, incline the text to whatever angle I want, and so on. So I could do a host of things there. So let me revert back to my original formatting. Next, I could also format the way the legend shows up. So I select this legend box, do a right click, format legend. And now I have options on the right hand side. If I want the legend to show on top, it'll show on top. If I want to show it at bottom, it'll show it at the bottom of the graph, left, right, and so on. Finally, I could also change how these lines in the line graph look. For example, if I wish to change how the line for sales in the Ontario region look, what I need to do is I select the green line, which shows sales for the Ontario province. While my cursor is on that line, do a right click, format data series. And now I could change the way this line looks. So I take my cursor to this very first icon on the right hand side where it says fill and line, click that icon. And here I have a host of options. For example, I could change the color of the line from the current greenish color. If I want a golden color, I could change it to a different color. I could also change the width of the line, make it thinner or thicker, whatever I want. I could also change the kind of line. So currently it's a solid line. I could change it to a dotted line and so on. So a lot of things I could do by changing these various options. So let me revert back to my original option. So that is how we could embellish our line graph in whatever way we wish to present it to an audience. The following lesson completes our study of the popular graphs and charts in Excel by introducing the column charts and the pie charts. We will now introduce the other two popular charts in Excel, namely the column charts and the pie charts. We'll illustrate them using the same data that we use for constructing a line chart, namely data from the file store sales, which contains data from an online office supply store based out of Canada. So let's open the Excel file store sales.xlsx. So earlier we had used this data and we had visualized the monthly sales for three provinces: Alberta, British Columbia, and Ontario. We had visualized the monthly sales for the year 2016 using a line graph. Now we'll do the same thing using a column chart. So for that, I go to Insert, and where you have these various options of charts, I would select this option there where it shows vertical bars. And if you put your cursor there, it says Insert a column, also known as a bar chart. I'll click on that. I'll choose the very first option, which is the most popular option. And a blank slate is produced. Now I would be filling up this slate with my data. So I do a right click, select data, add. I would first put in data for Alberta. I type in Alberta in the series name and the series values. I do a is equal to and select data, monthly data for Alberta in the year 2016. Do an OK. And you would notice my horizontal axis, instead of January, February, March, it is 1, 2, 3, 4, and so on. But I could always change it. I click on Edit. and select January through December from my column A as labels and do an OK and another OK. So a graph is produced showing sales of Alberta. I could always now add other provinces to this graph, namely British Columbia and Ontario. Once again, I do a right click, select data, click on add. I would add British Columbia. Select data for British Columbia, January to December. Do an OK. Edit. I select January through December. Do an OK. I could also now add data for Ontario. So add, click another time, add. Series name, I would type in Ontario. Series values, I do a is equal to and select data for Ontario, January to December, and do an OK. And I change the horizontal axis, January to December, another OK, and another OK. So this is my column chart produced. Now I could always now add in titles to this column chart. I could maybe the horizontal axis, I could do a boldface. I could change the font of the horizontal axis. I could do lots of other things as we did for the line chart. I could also add a legend to this graph by selecting the graph and on the right hand side, clicking on this plus sign where it says chart elements and selecting the legend box. So a legend is also put there. So lots of other things I could do to embellish this graph. One other thing that I can do is to change the orientation of this graph. Currently, it shows vertical bars. I can change it to horizontal bars. So how do I do that? I select my graph, do a right click, change chart type. And now a host of options are there. Currently, it's the vertical column chart. I could select a horizontal bar chart. So I click that option, do an OK. So my data is now put in a horizontal manner where my vertical axis now is January to December and the horizontal axis is the specific sales in those months. I could also convert this chart into a line chart. So again, I select this chart, do a right click, change chart type, select a line chart there, do an OK, and I get my line chart which I produced in an earlier lesson. We will now plot a pie chart using these data. So to plot a pie chart, let me first delete this current chart that I have. So what is a pie chart? A pie chart is a circle that is divided into sections, also known as pie slices, representing a proportion of the whole pie. So each slice represents certain portion of the whole circle or the whole pie. So let's insert a pie chart. And because in a pie chart, when I want to visualize the sales across these three provinces, I'll have to produce three separate pie charts so that they all fit into the same screen. Let me reduce the zoom level to 100%. So I go to insert, click on insert. Again, in the charts area, you would notice the circle there. If I put my cursor there, it says insert pie or a donut chart. So I click there. The very first option, the most popular option. But before that, notice I need to put my cursor somewhere in an empty cell other than my data. So I click insert, the circle, the very first option, the most popular option. I do a right click, select data. First, I'll put in data for Alberta. So I click on add. Series name, I give it a name, Alberta 2016. And series values, I do a is equal to and then select data January to December in the year 2016 for Alberta. Do an OK. You would notice that my months are numbered 1 through 12, but I could always change it. I click on Edit and select January through December. Do an OK. Another OK. I could now maybe boldface the chart title. I could boldface the legend, select the legend, go to Home, boldface. I could change the font size. I could also change the orientation of the legend. So right now it's beneath the pie chart. I can put it on the side. So I click the chart. Notice there's a plus sign next to it. I click on that. I click on legend, that arrow next to the legend, and instead of bottom, I choose the right option. So now my legend is on the right hand side. Once again, I could boldface it. I could change the font size. I only see January through October because I need to stretch this box a little bit. So let me do that. Once I do that, I see January through December. So that's my data for Alberta. You would notice that maximum sales in Alberta occur in July. If I put my cursor there, it'll tell you that that slice refers to July. It also gives you the value $73,534.45. And not only that, it also gives you what percentage is it of the entire year sales. In this case, July sales are 14% of the entire year sales. And the minimum sales occur in the month of November. If I put my cursor there, $3,760.81, representing only 1% of the entire yearly sales. I could produce pie charts similarly for British Columbia as well as Ontario. And because I want similar size pie charts, let me simply copy this pie chart and paste it so that I get a similar size pie chart. And then I would put in data for British Columbia. So I click on this pie chart, do a right click, select data, click where it says Alberta, do an edit. I'll change Alberta to British Columbia. So first I'll change the series name from Alberta to, I'll change it to British Columbia. British Columbia 2016. I would change the series values. I'll select data for British Columbia, January through December, and do an OK. Another OK. So this is a pie chart for sales in British Columbia. And in British Columbia, you would notice maximum sales occur in the month of August. If I put my cursor there, $85,026.35, representing 14% of the yearly sales. And minimum sales occur in the month of May. Once again, representing only 5% of the sales, the total sales in May being $29,532.09. Same thing I can do to construct a pie chart for Ontario. So I copy this, paste it, and I will change the data to that for Ontario. So do a right click, select data, click on British Columbia, click on edit, change the name from British Columbia to Ontario, change the series value so that I select data for Ontario is equal to, and then data for Ontario January to December, do an OK and another OK. So for Ontario, the maximum sales occur in the month of April. So if you put your cursor there, it represents 14% of yearly sales, $131,061.19. And the minimum sales occur in the month of August, representing 4% of the overall sales, the actual value being $43,580.39. We now make charting in Excel a lot more interactive by introducing something called pivot charts, which, as the name suggests, are based off a pivot table. Pivot charts in Excel. So, what is a pivot chart? So, a pivot chart plots data just as a regular chart does, like a line graph, a bar graph, a pie chart that we saw in a previous lesson. But the difference between a pivot chart and these other charts is that it uses data based off of pivot table. And why is that important? Because it gives us a lot more interactive filtering controls on the chart. We can subset a data, we can change the data in the chart itself and see how a subset of data would look like and so on. We can visualize different subsets of data. So that is what is meant by a lot more interactive filtering controls provided by a pivot chart. Let's see this by way of an example. We'll use the same file, store sales.xlss, that we used in an earlier lesson. So let's open that file. In an earlier lesson, we constructed a pivot table out of that file. The file data was given in the worksheet store sales. So this is the data, and we created a pivot table out of this data. And the pivot table, Excel put it in a sheet called sheet 1. So this is the pivot table. Notice whenever I put my cursor on the pivot table, if I do not see the pivot table fields on the right hand side, which I had intentionally crossed out, what I can do is I do a right click, click on show field list. And then I see all my pivot table fields on the right hand side. If I click anywhere outside, that field list vanishes. If I click anywhere on the pivot table, that field list shows. But I do not want to really see it. It occupies space, so I'll cross it out. But I now know if I wish to see it, how can I again enable it? So in an earlier lesson, what we did was we constructed line graphs, bar charts, and pie charts for monthly sales in the year 2016 for 3 provinces. The province of Alberta, 2016 January to December, province of British Columbia, and the province of Ontario. Now we'll do the same thing, but instead we'll use a pivot chart for that purpose. So how do I insert a pivot chart or a pivot graph? The first thing, I need to put my cursor anywhere on the pivot table. So that's important. I do not put my cursor anywhere in an empty cell. I put it anywhere on a pivot table. So I put my cursor anywhere on the pivot table. Then I insert a graph in a regular manner as I did in a previous lesson. So I go to insert, and let's first draw a line graph. So I choose the line graph options. I choose the very first option, the most popular option. And you would notice a template gets produced. The difference here now is this template is a lot more interactive. For example, you would notice I have options of selecting provinces, different provinces. I have an option of selecting different years. I can change the grouping of the years if I want quarterly data, monthly data, daily data, and so on. So because in an earlier lesson, we had drawn a line graph for the provinces of Alberta, British Columbia, and Ontario for the year 2016, let me recreate that line graph. So first I go to province. I deselect all the provinces. So I click on this down arrow, this menu drop arrow there. Click on that. I deselect all provinces and then select only Alberta, British Columbia, and Ontario. I do an OK. So you would notice in my pivot chart, I only see those 3 provinces. And also on my pivot table, I only see those 3 provinces. Further, in the previous lesson, I plotted a graph only for the year 2016. So let me select only year 2016. So I go to that drop-down menu for years, click on that, and first deselect all and select only year 2016 and do an OK. Also, I can go to order date, click on that, and make sure that only January through December months are selected and all other boxes are unselected. So that recreates my line graph, which was constructed in the previous lesson. But now the difference is it has a lot more interactive controls. So let's demonstrate that. So let me first expand this a little bit by dragging it. So for example, if I want to add one more province to this line graph, let's say I want to add the province of New Brunswick. So I click on the drop-down menu for province. I select New Brunswick. Do an OK. So now, instead of 3 provinces, I have plotted a line graph for 4 provinces. Further, let's say I wish also to include data for 2017. So I go to years, select 2017, do an OK. So right now, 2016 is all collapsed into one data point. So how do I convert it into January through December? All I do is I go to my pivot table, expand on the 2017 selection by clicking on that plus sign. And accordingly, in my pivot chart, my line graph, now I see both years 2016, 2017, January through December, January through December. And I can do a lot of other interactive controls also. For example, if I wish to see the sales not across months, but across years, across quarters, I could do that, and so on. So this adds a lot more interactive features to graphing capabilities in Excel. This lesson visually investigates the relationship between two variables by introducing the scatter chart, also known as the XY plot. We will learn how to plot and interpret a scatter chart in Excel. Scatter plots in Excel. A scatter plot, also known as an XY plot, is a visual representation of the relationship between two variables. So as contrasted with a line graph, a pie chart, a column graph that we studied in earlier lessons, this is a representation of relationship between two variables. Those other graphs were really all about a single variable, how that single variable is distributed. So the two axes in a scatter plot represent the two variables, and the coordinates of every point on the chart are the values of those two variables. So this visual representation will tell us whether the two variables that we are studying, are they positively related, are they negatively related, or is there no relationship between these two variables. Let us look at it by way of an example by opening the file height and weight. So let's open that file, height and weight, XLSX. So what is this file? This file contains data on the height and weight of athletes from a past Olympic game. So the very first column is the second name of the athlete, then the first name of the athlete, the height of the athlete in centimeters, the weight of the athlete in kilograms, the country to which the athlete belongs, and the last column is the gender of the athlete, male or female. So given this data, what we are interested in is in studying the relationship between the height and weight of athletes. How are these two variables related to each other? So we'll do that by visually representing that relationship by way of a scatter plot. So how do I insert a scatter plot? I put my cursor anywhere in an empty cell in the spreadsheet. I go to Insert, and these various options that I have for charts, I choose this option where it says Insert a scatter chart, also known as an XY plot. I choose the very first option, and a blank slate is produced. I can move this blank slate a little bit to the side So next, anywhere on this blank slate, I do a right click. I go to select data. So I would be plotting my scatter plot in this blank slate. Select data. Click on add. So since it is a scatter plot, it asks me for what do I need to put on my x-axis and what do I need to put on my y-axis. I can, if I want, I can also give a series name. If I do not give any series name, it will pick up a default name such as series 1, series 2, and so on. So let me put the height of the athlete on the x-axis and the weight on the y-axis. It really doesn't matter what I put on the x and what I put on the y, but for demonstration, let me put height on the x-axis. So I do a is equal to and select my height data. Shift Control down arrow. Same thing I do for my y-axis. I do a is equal to and select my weight data. Shift Control down arrow. And then I do an OK and another OK. So a scatter plot is produced. Notice every point on this scatter plot represents a particular athlete. The x-axis of that particular point represents the height of the athlete, and the y-axis for that particular point represents the weight of that athlete. Let us tidy up this scatter plot a little bit more by adding a chart title, adding axis titles, and also formatting it for better visual clarity. So let me add a chart title first. I can give it a title, height and weight of athletes. I could also boldface it. I can add a X axis title by clicking on that plus sign next to the chart and checking the axis titles box. So once I check that, notice I have the option to put in the axis titles there. I'll put in my X axis title. So this is the height in centimeters. I could boldface it. I could also change the font. I'll do the same thing for my y-axis. I put my cursor there. And I can type in weight in kgs. I could select that box. I'll boldface it, change the font. So I have added my x-axis title and y-axis title. Now, a little bit more formatting I can do for better visual clarity. Notice that currently the scatter plot looks all lumped together. The reason for that is the minimum height observed in my data is 136 centimeters. So let me format my x-axis so that my x-axis, rather than starting from 0, begins from a little higher number. So I get a better visual clarity in my graph. So let me start my x-axis from 125 centimeters. So how do I do that? I select my x-axis, do a right click, format axis. In the axis options, notice there are bounds there, minimum 0, maximum 250. So I'll change the minimum from 0, I'll change it to 125 so that my x-axis now begins with 125 centimeters. And I click anywhere on the spreadsheet and I can cross this menu item out. So now you will notice my scatter chart has changed. It has gotten a little elongated and clearly has a better visual representation than my earlier graph. I can also drag it and expand it. So looking at this scatter plot, you would notice that as the height of the athlete increases, that is, as you move from the left-hand side to the right-hand side in the chart, the weight also corresponding, there's an uptrend in weight. That is, generally speaking, higher heights are associated with greater weights. So there's a positive relationship between height of an athlete and weight of an athlete. Now, this scatter plot is for all the athletes across both genders, males and females. So I'll leave it as an exercise for you to separately draw scatter charts for male athletes, the relationship between their weight and height, and separately for female athletes, the relationship between their weights and heights. This lesson introduces an interesting and important charting tool in Excel, namely the histogram. We begin by understanding what a histogram is, and then in a subsequent lesson, we start constructing one. Histograms in Excel. We'll be spending some time in this lesson and a subsequent lesson trying to understand what a histogram is and then constructing one in Excel. The reason we'll spend some time on a histogram is because, firstly, it is a little less intuitive than column charts and other graphs that we have studied in the course, such as the line graph and the pie charts. Secondly, it is not as easy to create using Excel. And thirdly, perhaps more importantly, it is very similar to statistical distributions, which we will talk about in a subsequent course in this specialization. So in that course, we'll introduce certain statistical distributions, and the knowledge of a histogram would come in very handy. The easiest way to understand a histogram is to display one and talk about it. So consider this histogram of salaries of CEOs of small businesses. The basic idea of a histogram is to pictorially depict salaries which are in the low range, salaries which are in the high range, and salaries which are kind of in the middle. The horizontal axis shows the salaries, in this case in $1,000, and the vertical axis shows approximately how many people or how many CEOs had the corresponding salaries on the x-axis. For example, it seems that 2 CEOs had salaries around $75,000. 2 CEOs had salaries around $150,000. And similarly, 8 CEOs had salary around $225,000. Now, what does it mean when I say that 2 CEOs had salaries around $75,000? Excel here shows data in ranges, also known as bins. For example, the very first bin ranges between $0 and $75,000. And there are 2 CEOs who have their salaries between $0 and $75,000. Similarly, the second bin or second range ranges from $75,000 to $150,000, and there are 2 CEOs who have their salaries between $75,000 and $150,000. Now, what does it mean when I say between $75,000 and $150,000? What I mean is 2 CEOs have salaries greater than $75,000 but less than equal to $150,000. Similarly, 8 CEOs had salaries greater than $150,000 but less than equal to $225,000, and so on. So now that we have seen what a histogram is, we can give a formal definition of a histogram. A histogram shows relative frequencies of observations that fall into set bins, also known as classes or ranges. Let us again look at this CEO salary histogram. This is very typical of income histograms. A few CEOs have very high salaries, but no CEO really has a very low salary. Income histograms also generally follow this pattern. This histogram is also an example of a skewed distribution, in particular skewed to the right distribution, as contrasted to a symmetric histogram. A symmetric histogram roughly would have equal number of observations on both sides of the mean. For example, here is an example of a symmetric histogram. So in this histogram, if I were to slice this histogram somewhere in the center, I would roughly get two mirror images on both sides of the center. Now, how I constructed this symmetric histogram was I took 2000 random draws from a symmetric distribution and plotted a histogram. This is not real data. I made up this data for the purposes of illustrating what a symmetric histogram is. So now that we have seen what histograms are and have a good understanding of what a histogram is, we are ready to construct one in Excel. And that is what we'll do in the next lesson. Here in this lesson, we construct a histogram using data on salaries. The data analysis toolbox in Excel is introduced, which will often be used across various courses in this specialization. Let us begin constructing a histogram in Excel by first opening the data file that contains the salaries of CEOs of small firms. So let's open the Excel file. Let's go to Excel. And the data is contained in the file CEO salary small firms. So let's open that file. So what this file contains is it contains the salary details of a sample of CEOs of small firms. So column B contains their salaries, and the unit of salary is in $1,000. So we'll be constructing a histogram of this salary column. So to construct a histogram, first we click on data, and then we click on data analysis. However, if when you click on data, you do not see the option of data analysis, you need to do the following. So what you need to do in that case is click on File. At the very bottom, click on Options. Click on Add-ins. And then at the very bottom, Manage Excel Add-ins. Click on Go. And make sure that Analysis Toolpack and Analysis Toolpack VBA, both boxes are checked. And then do an OK. And now when you click on Data, you should be able to see data analysis. If you still don't see, perhaps you need to close your Excel and open it again, and then you should be able to see data analysis. But before we click now on data analysis, we need to set up our bins. Remember, a histogram shows observations, shows the relative frequency of observations across bins or ranges. So we need to set up those bins before we construct a histogram. So let's do that. So I start my bin range from 0, and I'll choose a bin interval of $75,000. So my next number would be 75. So my first bin is from $0 to $75,000. And I can now continue creating those bins. An easy way is I select these two, go to the bottom right till I see a thin plus sign and keep dragging it. And notice the bins get incremented, 150, now 225. It's being incremented by $75,000. So I keep going down. My highest salary in the data is $1.1 million. So I'll stop at 1125. The idea is that I should have enough bins so that all the data in my file, in my data file, should get accommodated in one of the bins. So I stop there, 0 through 1125, $0 to $1.125 million. So now I go to data, data analysis, a search for histogram. So notice histogram is there. I highlight histogram, do an OK. Another dialog box opens up. It'll ask me where my input range is and where my bin range is. My input range is in column B, B as in Boston. And notice there's an option for labels. So it's a good idea to select that option whenever Excel provides that. So I check on that. So what that now means is when I select my input range, my very first observations should be a label. Hence, when I select my input range, I'll select including the word salary. So I select this entire column. So that's my input range. Similarly, the bin range, when I select, because I've checked the labels box, I need to select the bin range also beginning with the label. And that's the reason why I labeled my bins as bins. So I select my bin range, including the label bins. Then I need to select an output range where I wish to put an output. I could also select a new worksheet, but I'll put the output in the same worksheet. So I select any empty cell to put the output in. So I select, let's say, this particular cell. And then very important, I need to make sure chart output box is checked. If I do not do that, Excel will not produce a visual plot of the histogram. So once this is done, I click on OK. And it produces a histogram. Okay. I can drag that histogram and increase it in size. I can further increase it in size. Maybe I can do away with this legend where it says frequency. I could give a different name to the histogram. Instead of calling it histogram, I could call it as CEO salaries, small firms. I could give a name to my x-axis. Instead of calling it bins, I can call it as salary in $1,000. If I want, I could also change the name label of my y-axis. If I want, I can also change the slant of the labels on my x-axis and so on. There's a host of options I can do. So this is a histogram we have produced out of the data. Now, a couple of points before we close this lesson. Firstly, notice the table that is produced next to the histogram. It's known as a frequency table. Why? Because it shows the relative frequency of observations across various bins. For example, it shows there are 2 CEOs with salaries greater than $0, less than equal to $75,000. There are a total of 13 CEOs who have in my sample data, there are 13 CEOs who have salaries in excess of $225,000, but less than or equal to $300,000. At the very bottom where it says more 0, what it basically means is in my data, there is no CEO who has his or her salary in excess of $1.125 million. So that's the frequency table. Another important point in constructing a histogram is how big a bin interval should I select. Notice in this case, I selected a bin interval of $75,000, or my bins were 0, 75, 150, and so on. There is no hard and fast rule as to what should the bin interval be. The idea is that I should select a bin interval which gives me the best visual representation of the data. So the recommendation is try out different sets of bins and go along with that particular set of bin which gives you the best visual representation of the data. Hello there. Congratulations. You have now finished the various components of this course and worked through all the exercises. This course was about introducing data analysis using Excel with the aim of getting to use it for more advanced topics in business statistics later. Those of you new to Excel gained a working knowledge of Excel, while those already conversant with Excel polished some of the specific Excel skills required for business statistics and analytics. Excel is a powerful data analysis tool, and all businesses use it in their day-to-day functioning. With the Excel skills gained in this course, you are ready to now apply these to various practical topics in business statistics and analytics that you will encounter in the remaining courses in this specialization. I strongly encourage you to continue with the remaining courses and to complete the specialization. The data analysis and inference skills that you will develop in the specialization would be very helpful in whatever career path you are pursuing. Thank you for taking this course, and congratulations once again. I hope to see you in the remaining courses.
Thank you for watching our video. We hope you found it helpful. If you enjoyed this video, please hit the like button below and subscribe to our channel for more videos like this. If you know someone who could benefit from this information, please share it with them. We would love to hear your thoughts on this learning course, so please leave a comment below. Thanks again for watching, and we'll see you in the next video.